Okay, ladies and gentlemen, here is part 2 to our screencast for today. So as you noticed when we went into the Hello World program, we had the message Hello World displayed on the screen. And really, as you notice, what occurred, it was the code that you see above, the system.out.println, parenthesis, quotation mark hello world, and quotation mark parenthesis, semicolon. And basically, this is what we call a system. A system is built in a class that is part of the standard Java library. So system will be one of many different functions that we'll see in the basic Java library. Well, out is an object of this class. Okay, so you notice that system is built-in class, but the actual out, or the output, as we know, that creates is an object of this class. So the word println refers to the method of what we call the system out stream. So when we put the word system and out together, it's a stream, and then the println is the method that occurs. And basically, in this case, it displays a single line of text, and the text that you want displayed must occur in between the double quotes. In this case, we call the system out println hello world a string literal. Okay, so in the case hello world is the string literal inside of those quotation marks. So just to do a quick review of the elements of a Java program, we call the system out a stream, hello world, println, that's the value of the parameter list in this case. A system is equal to a class. So even though we had a class at the beginning called Hello World, well, we have a class within here, and this one's called System. And out is an object of the system. Println is the method of this. And the parenthesis is the start of a parameter. The quotation mark is the start of a string. The actual string itself is Hello World. We end the string by using the quotation marks again. We end the parameter by using the close parentheses. And then the last thing that always comes as part of this is the semicolon, which we call the terminator, which basically means stop. This is where this line of program or code is to stop at that point. It doesn't mean that the actual program will stop, but it does mean that for that specific method, we've terminated what we want it to do at that point. So now that we kind of have the background on the programs, let's just quickly talk about errors. We're going to be making many errors this year, myself included. We're human beings. So, it's just part of who we are. And as we know, errors can be very simple, but they fall under three kind of categories. And errors can be simple, as I said, but they can also be pretty complex. The ones that we're probably going to be making the most right now are syntax errors. That's just the process. But we also have what we call runtime errors and logic errors. A syntax error is just the grammatical error. It's caught by the compiler in our case, Eclipse, and it shows it as a compiler time error. It's automatically found. It's usually easiest to fix. So Eclipse is showing that to you with those little X's. And even if you run it, you're probably going to see in your output something is not quite right. Basically, it can't run the code correctly until all syntax errors are fixed. And sometimes the error messages may be misleading in that it interprets the code one way and may actually give you a false output to make you think that this is what the error is, but it actually could not be. One of the big problems here is misspelling a command. For example, return instead of return is going to cause a syntax error. Runtime errors are errors that occur during the actual execution or during the runtime of the program. They're not as easy to fix. And again, the error message just may be totally unhelpful because it's going to misinterpret what the actual error is. So for example, and we haven't gotten quite to this point with our programs, but division by zero. If we're doing something that a program attempts to divide something by zero, it automatically terminates and prints an error message. So Java clearly in this case was not happy with the division by zero. Also, we have the third type of errors, which is called a logic error. And a logic error is just because it compiles and runs without getting an error message, it doesn't mean that the code is correct. So basically, in this case, the design or the algorithm may have a problem or an error. The actual calculation part may not be right. So, it is possible that the code compiles without errors. It's very possible that there will be no runtime error messages. But we actually notice that the incorrect action or data occurs during execution, so the output may not be correct. And again, these are the most difficult to fix and find because this really goes into the thinking behind the program. And that's why we're going to use comments quite a bit, at least initially, so you can actually see the thinking behind what you were trying to do, and that hopefully these logic errors will be quicker to find and solve. The other thing that you have to think about test cases or things, that you've done previously and being alert and test thoroughly. I mean, it's okay if your code messes up the first time, the second, or even the third time. But really think about the test cases and predict the results before you even execute the code. So, kind of just think ahead and maybe possibly predict some common logic errors that might occur in your code before you even start coding. So some examples here. In this case, we have an algorithm error. We're trying to find what we call the average of 5 scores, and we say that the execution in this case, which would be the sum of the scores divided by 2. Well, actually, we know that that's an algorithm problem because to find the average of something, you have to take the sum of the total number of numbers and then divide it by the total number of numbers, which in this case is 5, not 2. Also, in this case, looking at the implementation error, we have a problem here because in example 2, we typed in the wrong symbol in the source code because when we're trying to find the sum of something, we know that sum is addition, not subtraction. So a minus b is not correct. It actually should be sum is equal to a plus b. So, ladies and gentlemen, here's the end of our PowerPoint. What I would like you to do, and I will give you all some slides here, I would like you to create 2 new Java programs and 2 new classes, and 1 in each. And I'd like you to choose 1 PowerPoint slide for the first project, 1 for the second project, and I'd like you to take all the information on your first slide, put it out as a system output, and then on the second project in class, go ahead and do the same. Please make sure, ladies and gentlemen, at the very top you put a comment that says your name, today's date, the period. In the case of the name of the project, just go ahead and use the topic from one of the slide that you are creating the output from. So in the case here, if I'm using this one, I could say logic error examples. That would be my project name. Make sure that you save this, and again, we'll go over hand-in instructions today. If you have any questions, please feel free to come on over and ask me. Otherwise, enjoy your Java project.